So this is Jeopardy in style of the game. Let's take a look at this afternoon's categories. We'll start off with who am I? Why even try? Adjectives, influence energy, solving the process, and finally attack techniques. So the board, we'll start off with who am I for 100. So I'd call myself a cybersecurity and computing enthusiast. I just love to figure out how things work, how they fit together, history of them, and that plays into a lot of different things that you'll see here. Today, my day job, cyber range and scenario builder. I work for the company, the Ultimate Knowledge Institute, doing training scenarios. This gives me a lot of experience implementing attack techniques, implementing defenses, putting them together in some kind of meaningful scenario to show some concept. So out of that, for 10,000, someone who knows what matters, at least as far as what makes an attack technique work or not work, and something that makes it, roughly what level of effort is it. So why try? $100. So we've seen a lot of different things here on prioritization, and there's a common trend of organizations ultimately tend to focus on just what's common in threat intel. This is not a bad thing, it's just what they know and what's available. People buy VPNs because they sponsor podcasts. This is not sponsored by ExpressVPN, just FYI. Not that that's a bad thing, but it's a threat model that doesn't matter to most people, and yet it happens because they're sponsoring podcasts. Cyber insurance is broken, needs a new approach. Through my LLC, work with some small companies that just have a hard time getting it. The process is very cumbersome. Really want to improve kind of the threat model of the whole thing. And the $1 million why try? Not every target is worth endless time. This talk is mostly focused on the attacker perspective, just for time's sake. And so if I'm looking at it from an attacker, I'm trying to get some benefit out of this, and it's not endless time against every target. All right, so a quick thing here of adjectives. If you were here last year or saw my lightning talk, it's just looking at 3 ways you can bucket attack techniques so to even begin to make this process feasible. So if we start off with the first clue, the first answer, capabilities that are readily available in Kali Linux, this would be what is public. So public capabilities is one form of attack techniques. The next one would be modifications to public techniques, like applying signature evasion to a interpreter payload or something in that vein. That would be what is altered capabilities. So public capabilities altered. And finally, for 10,000, novel implementation of a technique or entirely new sub-technique, think something like a zero-day exploit that's bespoke. So those 3 buckets let us categorize, we'll say implementations of attack techniques. So they're either a public, something readily known, altered form of public, or something bespoke. So this brings us to the concept of influence energy, which is something I've been doing a lot of writing and work on recently. In general, it's the measurement of threat actor sophistication. We break it down by saying it's a time or money, could also use the word effort, used per target. We say time and money because, of course, we can exchange those two. You can buy someone else's time with money. And the per target is important. We'll cover that in a few slides of if you put together a campaign and use it against more targets, that has implications for the mitigations thereof. So this is kind of the table of influence energy on the left. And it's a 0 through 5 scale. It's not directly related to the summiting the pyramid, but certainly very highly related to that. It's just trying to say, all right, as we go up in influence energy levels, the number of attacker hours goes up by a factor of 10 each time. And then we can also put this in dollar value there on the right by saying, all right, something like $100 per hour for that. All right, so you might ask, why was that in powers of 10? And then also notice the game board is in powers of 10. And that's important because we want to use Fermi estimations. If you're not familiar with Fermi, Enrico Fermi was a physicist, worked on the Manhattan Project, and also did lecturing in university. And he loved to ask these, or do estimations and ask questions that seemed kind of impossible at first, but in reality, with just a few basic assumptions, you can solve them. And so a famous one is, how many piano tuners are there in Chicago? You might think this is going to take a lot of research and information gathering, but in reality, you can get a very close approximation within factor of 2 with just some basic assumptions about the number of people in Chicago. So the key thing with these Fermi estimations is they're solvable with a few basic assumptions, like we're talking about here with ATT&CK. Errors tend to cancel out with the logarithms. So if I'm off by, say, a factor of 2 in one of my elements, but I might go the other way in another element, they'll cancel out and my final answer will be roughly where it needs to be. So this allows simplification of what we might think are impossible problems. Like if when you read the talk title, you might think, well, that's impossible to assign a dollar value. Well, we start to make some assumptions here and we can put that together. So how do we actually do this? So start with the process for 100. We do need to start off by saying different people have different knowledge. If you're looking at my influence energy thing and saying, well, some attackers might be able to achieve in 1 hour what would take 10 or 100 hours for another attacker, you're absolutely right. And so everything that I'm doing with this process starts with someone, we'll say normalize it to someone with basic computing knowledge. I'm going to guess everyone in this room or watching online is well above that. You're probably at least at the influence energy 2, if not 3 or 4 level. So we need to normalize down to that in order to get the right starting point of what, if I was truly starting from 0, what would it take to be able to execute a given technique? The total amount of effort, if you're thinking about like actually using a technique, must be divided by number of targets. So if we're looking at something we're seeing in the wild, it's very different to say, was this used as a bespoke thing against a single target, like a lot of APT campaigns, or was it something that was blasted out? If you say develop your fancy bespoke technique and then throw it against 10,000 targets, it became a public technique at some point in there. We could debate exactly when, but it's much more detectable. Someone's done a write-up on it at that point and we can mitigate it. All right, so the actual process, 1,000. For each technique, you want to look at how many hours would it take to teach someone with no prior knowledge how to use a public version. We just start off with the public, the simplest. If you're familiar with Bloom's taxonomy, just throw this in here with my education background, this would cover up to the applies level. So you know about the topic and you're able to apply it in some useful capability of a target. Yeah. How many additional hours then, the next step, to teach someone how to alter that public version? So someone who already knows how to use it, but now you want to make a new form of it. And that's where you get into the analyzes and evaluates phase. So it takes more effort, not necessarily 10 times more, but often it would simplify that way. And then finally, how many additional hours to create a bespoke version? So taking that same concept, but finding some new way or novel way of doing it. This is getting up to the creates level of the Bloom's taxonomy. And this is important because the whole taxonomy with Bloom's deals with how we're teaching and how we're retaining different types of knowledge. So that's kind of the high level of the process. I want to spend the last couple minutes here going through a couple of actual examples. So, well, this is the first example is public web shells. So if we're looking at, again, public versions of these, require a nominal knowledge of, we'll say, active web content. You need to know what PHP or ASP is. I'm pretty confident I could get someone off the street and teach them those concepts. Again, they know how to use a computer and show, here's a web shell, and with 1 hour, they'd be able to use the web shell, like know what folder to put it in. But if we're talking about altering that web shell, that's now going to require some additional programming knowledge. The benefit to the attacker is this can now evade simple detection rules, but again, it takes more effort. I would say something on the order of 10 hours. There's a lot of background knowledge just related to programming, understanding the framework, and making sure that you can achieve the same objective. If we're getting up to bespoke web shells, so now you're talking about something that's, again, to a limited number target set, in-depth programming knowledge, you're probably writing something new, and intelligence of the target environment so that you blend in. This would be the hardest to detect, the hardest to evade, but also, by my estimation, something like 100 hours. Now, you might disagree whether it's exactly 100 hours or something else, this is where the Fermi estimation comes in. Whether it's 100 or 200 doesn't really matter. We're just looking, again, for that order of magnitude kind of thing. All right, look at another one. Valid accounts. I know some people in the room probably don't like this technique. Things like default logins, easy to learn. Again, pretty quick. Someone could get up to speed and be able to brute force a Netgear router or something like that. Altered valid accounts. Right, yeah, so the last one was just logging in with default creds. If you're actually brute forcing, now you need to have a tool. You need to understand some of the actual command line interaction. Again, we'll say bumps up to about 10 hours. Bespoke valid accounts, so now you're talking about, again, learning about a target, something specific to them, and phishing credentials from them to use that. This is a case where it's actually still the same as the, it's a different skill set, but roughly same effort as the altered form. And for 10,000, one more fun example. So if we're talking about network sniffing, public version of that would be something like Responder. Requires some networking and CLI knowledge. Again, figure something like 10 hours to bring someone from 0 to Responder Hero. If you're going to alter that, something like 100 hours. There's a lot of programming knowledge needed to make the modification and be able to, say, use that in an environment. And if we're talking bespoke network sniffing, just kind of show like another extreme example, talking about sending a team to a target with specialized equipment. So you're talking multiple people that need some kind of like field training with special capability, actual travel time. So here you're at something on the order of, we'll say, 10,000 or more. If you let your imagination run wild for what this could be. If this is a threat profile you're worried about for your house, you might want to either have something really amazing in your basement, or you might want to look at something else first. So with that, move on to final jeopardy, this whole thing. So the task here is to create a public repository of these influence energy mappings for every attack technique. And fortunately, I've done just that. This will be on the last slide, but this is a repository anyone can access, and it lets you, the ultimate goal here is, can we take all of these techniques and put them into a mapping to say, this is what you need to cover at different levels. So this is influence energy 1 as visualized on the navigator board. The darker things are, the higher sophistication they are. So the darkest ones are bespoke. There's only a handful at level 1. And then the darkest ones are things that don't really apply at this level. Based on initial analysis, you could, if you're only concerned about that influence energy level 1 threat actor, you could ignore them. I'll skip through these a little faster, but at 2, there's more things, and as you get to 3, there's still more things. As you get up to level 5, it's the whole matrix. So this is more applicable, I'd say, to say smaller, mid-sized organizations. If you're at a large organization, you probably do have to worry about more things, but this could still be very applicable to prioritizing. So that's the end of the talk. I'd love to connect with anyone, especially like risk management or insurance. Like I said, I'm working with a couple smaller clients on risk prioritization, and that's kind of the genesis of the whole thing. And thank you for listening.
Fascinating discussion. We have basically no time for questions, though, as a result of a very good overview. However, lots of ways to connect with our speaker, and certainly there is a good conversation going on in Slack. I encourage everyone to check that out for some thoughts around the subject. But thank you very much for an excellent discussion.
Thank you.